A very good afternoon, gentlemen. It gives me immense pleasure in welcoming you all to the webinar conducted by the Institute of Indian Foundrymen Chennai chapter. So the topic for today is what's a 3D scanner doing in the QA department? This is really an interesting topic and really a need of the hour. And we thank our speaker for taking time off his schedule and joining us today to make us rich with knowledge. So without further ado, I request Mr. Hema Prasad to introduce our speaker for the day.
Thank you, Vignesh. It's my honor to introduce today's speaker, Mr. Joseph Samuel. Mr. Joseph Samuel is coming from a small town in Satyamangalam, Erode district. He is a MBA graduate from Bharatiyar University and pursued sales as a career since 1998. He founded a primary school in his native place in 2000 and managed remotely till 2019. He worked with CAD companies by selling CAD software for the initial 12 years and then switched to selling 3D printers for the last 4 years. He is a co-founder of a 3D printer service company in 2015 and later he joined Infotech in 2020. During COVID years, he built products for Infotech. He is always like marketing and sales. His vision is to take the 3D scanner business to all corners in South India and add more products that add value to their customers. He is married and having 2 children. Now its floor is yours, sir. Thank you.
Okay, thank you so much. I would, it's a great honor to be in the presence of all the, big business owners. We have been selling these 3D scanners for a while, but primarily, okay, maybe I think I should share the screen and then. So I have done some activities in the past with Coimbatore chapter. We've done some activity in Shimoga, and we always wanted to do something in Chennai. I think this is a bounce back of what we did in Coimbatore, and so we are excited to work with the Chennai community as well. Now let me share the screen. Are you able to see the screen? Yeah, so Triple Infotech is basically a 3D scanning company, which means we have.
The screen is still not visible. Sorry, sir.
Okay.
You can put up your screen.
Yeah.
Yeah.
Yeah. Yeah. So Triple Infotech is a 3D scanning company. We've been offering services for the last 7-8 years. Business has been to establish ourselves as the goal application, because 3D scanner as an instrument is taking a lot. And it was initial, because people, but early, in mid 2000s, we saw they were also working with a previous company called Steinbichler, and that again is a German-based company. And so we were seeing the 3D scanners picking up traction over a period of time. And then in 2014, the couple of my friends, Ravi Chandra, whose name you see here on the presentation, and one more colleague of mine, Kavya, they started this company with an intention to establish ourselves, because eventually we are foreseeing a market that is emerging, where customers will take 3D scanner as an add-on device for their measuring and for the reverse engineering applications. So that's how the association with Zeiss started. Initially, we had a few Steinbichler 3D scanner machines, and then slowly, in the year 2000, early 17, 16, 17, at the time Zeiss took over. That single, currently it is 2 lens and a single projector kind of system that you see on the screen. So it's a little brief of how 3D scanner. So yeah, sir, I think let's just share a few highlights.
Yes,
What have we been doing in the last few years? When we're handling services business, these are some of the applications that we've been handling. Since there is network issues, so many other issues, I thought I'll share some of the interesting work that we've done. Especially in casting, we've done multiple activities, and after that we've got a lot of service jobs from especially from Coimbatore and a few companies in Shimoga. These are some of the highlighting areas that currently we are offering services. It's very similar to plastic and casting industry. So especially for export oriented businesses, we are doing a lot of 3D CAD comparison, because you want to see what is the warpage and shrinkage in the casting part compared with your CAD geometry. So 3D scanner is the only option for us to do this. And these are some regular reports that we are generating for customers in Coimbatore or in Chennai, in few Shimoga markets. And validation of the patterns, that's another great opportunity. And then we are doing as a service. Not everybody can invest on scanners, but the services business is really picking up, and slowly that conversion of existing service customers into buying products is also happening. So patterns, we are getting a lot of patterns, especially in Coimbatore, like places we have got 100+ pattern makers. You have a lot of inquiries for inspection on patterns. And then there are good number of tooling companies today. We are using it for, especially for what do you call as blue matching, because both the casting industry and plastic component manufacturers want to see how the mold and the die, the core and the cavity mates. When it is mating, how does it look? Is it 0-0, or is there any waviness in the part? Do they have to rework on the mold? Sometimes for tool maintenance. So these are very, very draft angle, of course, when you want to compare it with CAD. So these are some mundane activity that we are doing when it comes to inspections. And of course, what is opening up as a new area for us is maintenance of the tools, which is still, because a lot of automotive companies import the tools from Korea and other places. So the maintenance of the tools is something opening up as a new application, so which we are also doing. Machining, to some extent we can support, because when it comes to machining parts, customers require very, very high tolerances, whereas in scanners we are talking about smaller components as small as 100 mm. We are talking about 10 micron accuracy, the device accuracy, and it goes up to 30 microns for a 500 mm part. And then if it goes beyond that, depending on the lens that we are using, the accuracy keeps adding up. The stitching accuracy keeps adding up. So when it is really about a single digit accuracy requirement, then scanner is not the solution. But then we are seeing to stock checks, what is the elements that we have. And after machining, what is the flatness? That is one of the GD&T parameters you may want to see. So there are some opportunities opening up. People have started accepting 3D scanners for certain level of tolerances, because though for machined parts, people prefer CMM. But in our case, when there is a requirement of around 20 microns, smaller components 10 microns, there is always a scanner possibility of us supporting for machining components as well. So this is just a summary of how our existing service revenue operates within the inspection area, very particular to casting industry and tooling industry. But of course, on the lot of other areas, we are working. For example, we are doing reverse engineering projects. We are working with a few OEMs. We are doing about 12 cars a year, which means completely tear down the parts and reverse engineer. That's a very, very different application. So this is just a summary of what we are doing and how we are addressing casting and tooling inspection. So it gives you a clear idea of how you want to look at 3D scanner in the future. And these are some applications that you may want to look at. And then some of the other things that as a solution we have for scanning, these are some interesting slides you may want to see. I can share them with you. What we believe from Zeiss as a community, Triple Infotech included, scanner is actually becoming a part of the entire process. Because if you look at a few years ago, in the early 90s, late 90s, we had AutoCAD, and we all used to draft. I'm not an engineer, but I've always seen people drafting because I'm in this engineering field for a long time, more than 20 years. So drafting, 2D, AutoCAD, they are synonymous. And then suddenly, people launched 3D softwares, from the Autodesk we had Inventor, from there was SolidWorks, and then, you have all the other softwares. Now, when people started adopting 3D, it became a little more easy for them to discuss because you can pan, you can zoom, you can, section, you can do a lot of things, you can assemble, do a lot of things. And so what currently metrology as an area going through is shifting from 2D based to 3D. That's what we physically see, companies adopting, which means my inspection reports are not going to be merely tabulation columns and numbers. But when I shift to 3D, and it's very easy for me to use this 3D scanning in every stage. For example, in your tool making, you want to have core and core box, right? So if I can 3D scan both the core and core box, and then merge it in my software, assemble it in my software, and see if there is any clearance, right? So it gives me a good idea how my end part is going to be. And so I can make that correction in the earliest stage. So currently we are seeing, especially in the European markets, we get a lot of case studies where a lot of customers are making 3D scanning as a part of the whole process, not just inspecting at the end phase where casting is inspected at the last phase. So you can, I think we will have industry practice going forward where every stage is going to be digitized and kept for us to do a future reference. Pattern can be inspected. You have mold, both core. When you inspect, you can actually scan the whole thing, assemble it in the software, and then actually, if you want to cross section and see if there is any issues right in between the mold, right? So this is what we are observing. That is why we are saying, what is casting doing? What is 3D scanner doing in metrology or in the inspection? This is what it's doing. It is trying not just to inspect the end part. 3D scanning, because it can communicate to in 3D, because it can make you visualize you in 3D, it is actually addressing every stage of the manufacturing process. And so you can address the problem then and there, but at the same time, it's about storing these data for future references, storing these data for stakeholders communication. So this is where currently the 3D scanner stands. Of course, we have a lot of range of scanners. We have different types of technology. All of that is fine. But the scanning process across technology remains the same. I keep it on a table. I 3D scan it. Of course, I give different rotations. I have a rotary table, so I'm not getting into the process of scanning. But once it is done, you get a very clearly refined mesh. And you can see in the picture, you can also pick up some very small dents as well. So once you have the scan data, you can do a lot of things. You can do reverse engineering. You can do additive manufacturing, of course. You can do CNC machining. Some of the, you can generate programs even through an STL mesh data. And of course, for quality inspection, you can verify with your CAD and do verification of your casting. This is the message that we actually want to share with the casting community. It could be into anything, gravity, sign casting, patterns, pattern maker, PDC, or an investment casting, a process. 3D scanner will help you capture, all your processes, digitize them, keep it for your future references, inspect them, make modifications, because now we have 3D data, and communicate to people, not just with numbers tabulations, but with actual data, right? So this is how Of course, all this is unknown. And how does 3D scanning help? It can help for simple parts, large tolerances. It can also help for complex parts because it's a combination of many things. When I want, I have a large part, then I have something called a handheld scanner. So I can use a handheld scanner and then take the scanner to the component and then 3D scan it. There are, we have LMW as a customer. Their rings are about 1.8 meter mm. 1.8 meter ring. It's a huge one. So that cannot come to a CMM room. There are large castings in big companies. So it cannot come to our room. So I have a portable handheld device. I can take it there and scan it. And so there, when I use my hand, of course, there is a bit of tolerance. And so for larger parts, larger castings, you don't have to worry about tolerances. You have higher tolerances. And so it's easy for me to use a handheld device. For complex parts, for tighter tolerances, it could be a small plastic automotive component, it could be a home appliances component, or it could be casting itself for aerospace, pressure die cast part. So you have higher resolution lenses like what you see on the picture. We have something called ATOS-Q with a 12 megapixel camera. So any complex details can be captured. And so for casting or for any other industry, there is different solutions for different size of parts. So in 3D scanners, we always ask what is the size of the part and what is the lowest wall thickness, because that is what determines which camera I use, what is the lens that I want to suggest. It doesn't really matter how heavy part is because casting parts are very heavy. So it doesn't really matter. If it's too heavy, too big, it doesn't really matter. All that matters is what is the resolution that is expected, what is the resolution, what is the accuracy that is expected, and the accessories. We can use 3-axis rotatable. We have a manual rotatable. We have single axis rotatable. It just rotates in one axis. We have different kinds of stands for us to access. In 3D scanner, it is all about how do we access the component. Sometimes deep holes. How do I access it? It's all about additional accessories that are used to ensure that I capture all the sizes. So here in 3D scanner, the part size is really not an issue. Here you see a large car door, pattern there. It is being measured. So we have a trolley based stand. It's called a column stand. You mount the camera there, and then you can take it by section. I have a 500 mm lens, capture 500 mm, move, and then capture another 500 mm, move it. And so I can move the scanner all around. So for any of you manufacturing larger parts, that is not the issue. Scanner is not the limitation. But we can also suggest you the handheld scanner. We can use even more effectively than the column stand one. So in terms of the sizes, in terms of the complexity, the scanner is not going to be worried. The only area the scanner is going to be worried is how do I reach certain undercuts. So that is where the challenge is. That is the only limitation scanner has. If my human eyes cannot see, the scanner will also find it very difficult to see. For example, the depth ratio here you see, it's 1:3, right? So it depends on the outside diameter. If it is 10 mm, it can penetrate. The light can go up to 30 mm. So that is the only challenge the 3D scanner has. And then the other challenge also is the reflection, because it is light-based device. So when the light hits, sometimes the glossier parts tend to reflect. And so the scanner will find it difficult to see through a reflective surface. So we may have to dull the surface by applying, spray, non-destructive spray people use. And so, any complexity, it can support you in terms of digitizing, and any sizes doesn't have to worry about. And there are options for manual scanning, which means, I can scan it using, put it on a tripod stand or put it on a manual stand like this. It's easy for me to do. And there are completely automated systems, very expensive automated systems, where mount the camera on a robo like this, and then the part fixed on rotatable, and then leave the job to the robo and the whole system. So customers can go for manual systems, or automated systems. In car manufacturers use automated systems. We have system in Toyota Vidhi, where the car is moving, it has to scan, the outer body and, verify a few dimensions, especially the surface area. Is there any dent and things like that? And so that is all completely automated system. It is called scan box. It's like a box comes with certain dimensions depending on the component customers can buy. So the entire casting process can be addressed by our 3D scanning solutions. And so the one is digitizing the entire process stage wise and keeping them for future references. And then look at how you want to communicate. So like I said, in AutoCAD it is 2D, but when it moved to 3D, we were able to rotate, pan, and zoom. That is exactly what is happening in the inspection space now. And customers are asking for 3D based inspections, because not everybody can understand a tabular column. A non-technical person may be a part of the project, could be a marketing person, or it could be a owner of the company who is not technical. Or today communication is 3D has become very, very mandatory now. We have to communicate to people in 3D. So if I communicate to people like this with colors, with dimensions, like a ballooning, different shades, and then giving them a color map, like a heat map, right? So it's very, very easy for anybody to look at this picture and immediately make out where is it wrong and what is the wrong. For example, here, wherever you see, red shades, it is more than the tolerance expected. Wherever you see blue, it is minus, material is lesser than what is required. And so these are very, very important communication tools. So that's what we've been telling prospective customers and customers. Scanner is not just a measuring device. It's primarily a measuring device, but it is more than a measuring device. It is more a communication device. I have the data, I 3D scan it, and then if I need to communicate to my customer or my supplier, this is probably a better way for us to communicate. And so it is image based, it is picture based, color based, and then along with it you have numbers and texts. So your audio GD&T parameters, your 2D dimensions, whatever you want to communicate. You also want to import a chart, with all the like a tabulation column, you can do that. 2D dimensions, do you want to inspect? That is possible. So for us, the reason why we want to take this message across is 3D scanner is people think, okay, it's still far off, we cannot use it, we'll have to still rely on CMM. But I think the time has come, especially to our country where we are focusing heavily on manufacturing. Now we'll have to take some load away from CMMs. A lot of things, if you can eliminate and then put it to scanners like equipments, and then use your CMM only for critical dimensions and the dimensions that really matter, like single digit accuracy. And then CMMs can be used a lot better, and a lot of things can be pushed to equipment like scanner, because scanner is very, very easy to handle. Anybody can handle. The CMM only certain people can handle, people who are expertise on that. But this is like more like a digital camera. Anybody can use, because these are sensor based devices and it's driven by template. You cannot make mistakes, but the camera and this whole system will not allow you to make mistakes. When you're scanning, you're only scanning the right things. And so for us to train anybody, even a +2 student or an ITI or a diploma, anybody is easy, because once you scan, and then it can go to an expert who wants to inspect. So the scanning eliminates high level skill that is required for digitizing your data. So like I said, there are so many advantages. One is digitizing the data, storing it for future references. The next important thing is communication, like what you see on the screen, communicating effectively in 3D with colors and numbers. And the third is, how do I remove the skill part in the inspection? That is the most important thing, because the components are lying sometimes in front of the CMM lab, metrology lab for a long time, 1 week, 2 weeks, sometimes 1 day, 2 days, because it doesn't have enough time. CMM is very, very busy. And so, the NPD people have to wait till everything is done, and then you wait for the results. But here the scanner, you can do it quickly because don't set origin. There is no fixture requirement. You just keep it on the table. You just scan it. Once you digitize this, you can measure when you want on the go. And doesn't need a very high-end system for inspection. We give multiple licenses for inspection people. If you buy a scanner, at least 10 licenses for inspection can be given free. So there's huge amount of advantage when we move into scanner. That is why scanner is trying to barge into your metrology department, because it wants to take away a lot of burden away from CMM and other conventional devices, and also give the user some flexibility of using the device in a very casual way, and then doesn't require a lab setup. It doesn't require AC, and so much of advantage scanner brings, so that 3D scanning can be a little more effective. Any industries, any person can make inspection more user friendly, and then consider it. I don't know how to say it, but you don't have to be so focused like you are when you're using a CMM machine. It's taking that heaviness and burden away in that application and making inspection a little more easier exercise for the users. And so there's so many things we can talk about Zeiss. I really don't want to, but some of the first article inspections in some components, right? Specific areas you want to see. I want to see deviation to CAD. I want to see wall thickness analysis. I want to do GD&T analysis. I want to do material allowance check, right? So any given part, some of these things can be done. It's somebody scans it, and it does it. It's all menu driven, so it's not a lot of skill involved. A classic example of a scan box. Currently, we don't sell this. Zeiss directly sells this, but we still take the message across, because the scanner itself currently has already found its place in the metrology lab, in the quality assurance department. Now we are also propagating this message of not just scanners, but keep this idea of owning a scan box in the long term, because the industry is going to push us more and more to do things faster and faster. We're already under a lot of pressure to deliver faster. So these are some equipments that you can keep it in mind. While currently what is affordable is handheld scanner, or a blue light scanner, which can be mounted on a tripod and column stand, things like that. Now that is going to be in the adoption stage. Now what is going to happen in the future? We will have equipments like this, scan boxes, where the whole process can be automated and then monitored remotely as well, right? So I just keep the box component there in the fixture, and then run the program, and then it keeps scanning, and then the software keeps comparing and throw up results like this. So if you see here, it gives you the datum clarity. I mean, you know exactly what is the datum points here. It tells you what is the nominal dimension, what is the deviation. It gives you clear deviation with all symbols that are necessary. And red is not accepted, and green is accepted. So you can work around this to see what kind of results you want the screen to show you. And then this is applicable both, a manual system and an automated system. Software remains the same, except the programming additional modules will add on. But then the results, what you want to see, is pretty much the same. So trend analysis, what is 3D scanner doing in metrology? It wants to do trend analysis, because today trend analysis become very, very important, because customers certainly might ask these kind of reports, because they are working with us consistently, and they want to see if all the processes in our company, manufacturing processes, are okay. So how do they know that? They want to see how we are doing for the last 6 months, how we are doing for the last 1 year, how we are doing for a particular component for the entire life cycle, or at least till the contract exists. So there's so many reasons customers will have to ask trend analysis. The software offers you, because unless you digitize with our CMM data or any other data, coming up with the trend analysis is very, very difficult, too complex. But otherwise, let's say for a crucial project, I start 3D scanning from every stage and retain the data. And I take 1 or 2 samples from every batch of production. I 3D scan it and retain it in my computer. And suddenly customer says, I want to see the trend analysis. How have we been doing? I mean, of course, they keep inspecting and rejecting. That's a matter. But even there are customers who voluntarily do this and then submit a report. So this is how I have been performing for the last 2-3 years, or for 6 months or 1 year since we started the project. And so this is really, really handy tool. So for us to do this kind of analysis, we need 3D scan data, because when we step into 3D, we are not doing just the inspection, but now we are more talking about analysis. Inspection can be done, of course, but it goes beyond inspection. We are starting to do analysis. I spoke about how I can assemble 2-3 components together and do an assembly level analysis. Are they mating properly? Is there too much of gap? Or is there too much of interference because of which it's not assembling properly? And so when you switch from 2D to 3D, you're not just measuring, but you're also doing analysis. That is why we want to be in metrology department. That is why Scanner is trying to barge in, because Scanner is saying, I'm no longer a reverse engineering machine anymore. Please don't treat me like a reverse engineering equipment. Of course, even for reverse engineering these days, you need high resolution data. Otherwise, a curve can become a flat line and the whole geometry will not hold good. So it's no longer a reverse engineering tool, but the Scanner is screaming out loud and saying, customers, please look at me as an instrument for inspection and beyond that, analysis. That is why we're really aggressively promoting. A great example here, wear monitoring. How do you analyze this? This is impossible without entire surface data. So if I need an entire surface data, I need 3D scanners. And there are some features in one of our technologies where the dimensions which is on the CAD can be projected onto the part. Because I feed the CAD, and then I ask the software to project my dimensions on the component. And then I can do marking. Back projection marking is what we call here in a software, one of the high-end softwares. I can actually physically mark there. Let's say I want to remove some material there. I can actually mark. That's what the software is showing you. And so we are moving away from a traditional way of inspecting, analyzing, to more visualized way of looking at things in 3D. That is why the Scanner wants to be there in the metrology department. CNC machining, there are blanks. You can actually capture the real geometry and check for material allowance, and then align it with your CNC systems. People do collision tests. We really don't have first-hand experience, but I thought these are some informations that customers are doing. We have case studies on this. Any experimentation that needs to be done on this area, we can always take Zeiss expertise and try some of these things out. And so the Scanner has to be looked beyond just a measuring instrument. So this is another interesting feature called the live tracking, right? So here is what he's saying. He's aligned the CAD there on the software, and then here is mounting the component, the cast onto the fixture based on the alignment method that you use in the CAD. And now he's going to see how the component is comparing itself with the original CAD based on your analysis. So these are live tracking. It's very helpful in your assembly situation, because a lot of components are already assembled and you want to introduce a new component to that. They already have aligned themselves in a certain way. And then when you want to introduce a new component, how does it fit in? You can actually do a live tracking. These are some few examples that we have. We've still not implemented these kind of high-end features in India because scanning itself is picking up. But these are some of the features that are being already used by people abroad. Other countries, we get only stories of them. Yet to find ourselves being used in our own country. But then these are something that we can look forward to. These are some advanced features like back projection, live tracking, and we also have what do you call probes. The next one. So some geometries you can't address with complete non-contact. You want to touch it, and so if I am using a scanner, can I touch certain areas and measure the dimensions? And so the introduction of touch probes have also found its place, within the scanner environment. And so these are definitely revolutionary features. For example, I have a scanner. I want to check the depth of the hole. I can't access the depth, through a scanner because it cannot see. It cannot, go in properly. So I have a probe to address that need. And so this is how the scanner is evolving, and it is moving towards addressing larger problems than just merely scanning few dimensions. Going forward, we are also looking at how we can merge the CT scan data along with our 3D scan data, because a lot of casting community wants to do CT scanning or X-ray, whatever, because they want to see defects within the component inside. And so let's say I have a X-ray data like this, or a CT scan data, and then I can bring it in. Currently, the software is currently being, they're streamlining all the softwares and bringing all the hardware under single software. Most of the work is done, but eventually you will see Zeiss Inspect software with all these modules will be able to handle multiple devices on a single platform. So what that gives me is the exchange of data from one device to another. My 3D scanner gives me an STL file. My CT scan gives me another format, and I can bring in this data because my scanner cannot penetrate, but my CT scan can penetrate, X-ray can penetrate. So I can merge these two data and then generate a report out of it. These are going to be very extraordinary reports for us to share, to do some analysis. And so, this is called GOM. Now it's all become Zeiss volume inspect. I can actually estimate what is the volume, especially if there is a defect inside. What is the volume of the defect? What is the volume of the whole product? Diameter. And so a lot of things I can analyze sitting here with multiple instruments, and software being a single platform. Even today, for all the hardware that we have, all the scanners that we have, software is single. There's only one software. And slowly, all the other hardwares are also going to be accommodated in the same single platform. And so there's so many things. There's so many things. I think I can keep going on, but I think that's the gist of what I really wanted to share. And we really wanted the entire manufacturing community to not look at 3D scanner as some luxury product that we will use in the future sometime later. No, the product will address some real problems right now, and it let you address very easily, very effectively, not just address those dimensional needs, those measuring needs, but it will make our whole measuring process, inspection process a little more lively, a little more colorful, a little more informative, a little more convictive, because you see visually all these images, you are more convicted than looking at a tabulation column and numbers. And when you are convicted of certain things, so your communication is going to be to your customers. Your customer is is going to be really appreciative, because it comes out of your visual observation of data, inspection of data, and then there is a lot of thing that is going on between the supplier and the customer. So a lot of things you can do. This is what I showed you initially, applicable for both plastic and casting industry. And so I think I've given you enough reasons why the scanner should be there in the inspection department. If you want to summarize it, it takes away the burden of needing to have a skillful engineer. Anybody can do it. It takes away the complexity. It takes away the what do I say? it brings in portability. I can take the scanner anywhere. It brings effective communication in the system. It lets you digitize the data so that you can do future references. And because of digitizing the data, you can do a lot of analysis, like assembly analysis, like the trend analysis, and and then so a lot of advanced features like live tracking and back projections, probe-based inspections, and so I mean, there's so many reasons for customers to invite scanner into their metrology lab or into their inspection lab. I hope it was informative. I mean, we are really having good times doing a lot of services to customers. But when it comes to buying, of course, there's still a lot of resistance. But I think over time, customers will start realizing the need for it. That is why these kind of sessions will help. In customers, anybody wants us to visit their facility, showcase some of these features. If they want to realize them, physically see them, we are open to do it, sir.
Hello.
Yes,
This
sir.
is Thiagan. Can you
Yes, sir.
audible?
Yeah, I
Yeah.
can hear you.
Yeah, you're audible.
Yeah, I would like to know. I can say after your
Okay, thank you.
Yes.
Any other questions, gentlemen? Right. If anybody has any questions, please do raise your hand or speak up.
One more question, Siddharth,
Yeah.
to the speaker. Sir, you
Yes, sir.
deal only with the GOM, geometrical optical measurement, GOM, and
Yes,
ATOS?
yes, sir. Yes, sir. Yes. Yes, sir.
Not
Yes.
any other
Norm is
company.
the,
Not any other company.
no, sir. Not any other company, because we are
Okay.
affiliated to only Zeiss. We are
Okay.
not doing for any other company. For example, this is cast part that is 3D scanned, where he has scanned
Okay.
on both sides.
Hmm.
Since I've scanned, inside and outside, I can actually do a cross section like this. And
Yeah.
this is possible.
Yeah. I know this thing. Yeah. Okay. Then
Yes.
just I asked you are dealing with any other company like a Cryoform or something.
No,
Polyworks.
sir. No, sir. No,
Okay,
no.
right.
Polyworks, no, because anyway, the software here is free. So we
Yeah.
don't need to buy Polyworks, because
Okay.
only for advanced modules we need to buy, but otherwise basic inspection, GD&T parameters, mesh
Okay.
editing, 2D dimensions, all of this is free for you. You can use it in 10 machines also. If I have to buy
Okay.
Polyworks, then it costs me money.
Yeah, correct. Okay. Thank you.
What
Yes,
is
sir,
the
yes, sir.
accuracy we can measure?
Sir, again, it depends. Like I said, depends on the lens. For example, if I use I'll show you that. So, for example, here in the blue light scanner, you see the there are two versions. One is 12 megapixel and the 8 megapixel. I think you are able to. I'll take the laser point. This is 8 megapixel, which is highlighted, and the right on top is 12 megapixel. Let's say, for example, I'm using a 100 mm lens. In my 100 mm lens, my point-to-point distance is 29 microns, right? So we all talk about megapixels in camera. So here again, we have the same thing. In a 12 megapixel camera, it is 29 microns. In an 8 megapixel, it is 35 microns. So in terms of measuring, what is the smallest size I can measure? It will be about 10 times of the point-to-point distance, 350, 400 microns. Feature you can measure. Accuracy again depends on what is the lens I'm using and what is the camera that I'm using. So I'm using an 8 megapixel, 10 megapixel lens. My point-to-point distance is so small that it will give me as low as 10 microns. As I go, let's say I'm using 8 megapixel, but my lens is 500 mm. The points are getting scattered within the 500 mm area. So my point-to-point distance is 152 microns. My accuracy reduces from 10, because the points are getting scattered, it will go up to 30 micron accuracy. So that's like a range in 3D scanner. It's always like a range. A range because it is taking millions of points. In CMM, let's say you want to measure let's say a diameter, you'll probably take 10 points, 8 points, whatever, and then you will give me a accuracy. It'll obviously be a single digit accuracy. Here, it'll take a lot of points. It'll consolidate all the points, give you an average value. So it'll always look more than the CMM value. So that's some guidelines of how to understand accuracy in scanner.
Does it require calibration?
Yes, sir. Yes, it requires calibration once in a week. But once in a year, Zeiss does calibration in their setup with all those artifacts and all that. But you get a calibration plate for every lens that you buy along with the system. And so you can do it in-house. We teach engineers on how to do it. And also tell them what are the right results. But if there is any deviation, where will the software alert? How will the software alert? So based on that, they can recalibrate the system. But they need not send it to Zeiss every time. Unless there is a real problem in the device, they can calibrate it themselves. It's so easy.
What is the weight of a device?
This particular, this is a high-end one. So this is about 4.5 kg. It can sit on a tripod or a column stand. The smaller one we have, which is 2.5 kg, same technology. A handheld device, which is even more lighter, it's less than a kg. Yes, sir. Anything else?
All right.
So, we have a lot of alignment methods. So, we can discuss a lot of things in detail. This is just a teaser. Just want to throw some light on what all it does in the metrology lab. So hope it was useful. Any anything in detail you want me to come down, please let me know, sir.
All right, sir. I think just based on the number of questions we've been having, I'm very much sure that it has been a very fruitful session. You have brought about some of the latest meteorological technologies which are being used in the country right now. So we thank you for your time, and I thank our audience as well for spending this Saturday for a very valuable and fruitful session. As always, we'll have our technical sessions on every Saturday through IIF. So please stay tuned for more. And I personally thank our speaker for the day for such a knowledgeable session. So thank you guys, and we will keep you posted about the other upcoming sessions. This session also will be available on our YouTube channel, IIF Chennai chapter. If you want to have any doubts, or you want to revisit the session, you can very well go there and have a look at it. So I thank you all. Thank you, sir.
Thank you, sir. Thank you so much. Yeah.